Now in this chapter 3, we shall continue to talk about scarcity and the choices that societies therefore have to make. Principally, the first fundamental economic question, which is what to produce, right? We'll talk about that in some more detail, and we'll be using an interesting diagram to illustrate that choice, okay? We'll talk a little more about opportunity cost, and as we've learned in chapter 1, opportunity cost includes implicit cost. It's explicit cost as well as implicit cost. And then finally, we will talk about something called comparative advantage and trade, okay? And let's begin by introducing the very important concept of the production possibilities frontier, or PPF for short. So this goes by the acronym PPF. And so what is the production possibilities frontier? First, let me lay out some background here. We have a very simple economy in mind. This here is a too-good economy. So this is an economy that produces only two goods. So this is a big simplification. Remember, we learned in chapter 1 that economists proceed to construct these economic models, correct? And what do we learn about economic models? They are a simplification of reality, correct? Because reality is very complicated. In order to focus on the essentials, economists often make these big simplifications. So this is our big simplification in this case. Our economy here is a too-good economy. Only two goods are produced by this hypothetical economy, right? So what is the production possibilities frontier? It says this is a line joining all the combinations of goods and services that an economy can produce given its available resources and state of technology. So what is it? It's a line that joins all the combinations of goods and services that this country can produce given its available resources of land, labor, capital, and entrepreneurship, right? Remember, these are all scarce resources, right? And you also have there, in this mix, technology, right? So let's see what this looks like, PPF. Can we make a diagram for this PPF for a too-good economy? This is what the production possibilities frontier looks like. Let's focus on that diagram. Now, in this diagram, physical units of goods are being measured along the two axes. This here, of course, is called the x-axis, and this is called the y-axis, correct? So what are we measuring along the x-axis? We're measuring physical quantities of cell phones in millions, right? So this point here, well, that's 1 million cell phones. And that's 2 million cell phones, right? Now, what are we measuring along the y-axis? Along the y-axis, we are measuring DVDs. And these two are being measured in millions, right? So this here is 5 million DVDs, and then that's 9 above that, and so on, right? Is this completely clear to you? Right, now we have the blue curve, which is passing through points A, B, C, D, E, and F. That blue line is our PPF. Now let me explain this in a little more detail. If this economy decided to produce only DVDs, in other words, if it decided to devote all its resources to producing only DVDs, by this graph, could you tell me the quantity of DVDs that this country could make if it produced only DVDs and no cell phones? what quantity of DVDs would be possible to make? 15 million. You see that? And that happens to be point A. So what is point A? Point A is when only DVDs are produced. All the land, labor, capital, and entrepreneurship of this country is devoted to making DVDs, right? At the other extreme, consider point F. Now, what's true about point F? What does point F represent? Point F represents the quantity of cell phones that this country could make if all its resources were devoted to cell phones, correct? Of course, this country can produce both goods if it so chose, right? And what combinations of both goods are possible for this country to make? Well, those would be points like B, C, D, and E, and all points in between. Now, we've only mentioned a few points here, but clearly a point like that point, let's call that point F, well, F would be possible to produce as well, wouldn't it? So that's what the production possibilities frontier is. It's simply a nice way of showing all the combinations of goods that are possible for this country to make given its resources, right? Now let me ask you a question. Would a point like this here, let me call this point G, would a point like G be possible to make? Now, when I say point G, what do I mean? Remember, every point in this graph represents a certain physical quantity combination of cell phones and DVDs, correct? Every point on this graph is a quantity combination of these two goods. So let's consider quantity combination represented by point G. Now, is this possible? Is this combination possible for this country to make? The answer is no. Now, why no? Because you see, let's compare points G and D. Let's compare these 2 points. Now, we know that quantity combination D exhausts all of this country's resources. Am I correct? Quantity combination D is possible to make using all the land, labor, capital, and entrepreneurship of this country, right? Because how do I know that? Because point D lies on the PPF. And what's the definition of the PPF again? All the combinations of goods that are possible to make given the scarce resources of this country, given full use, that is, of all the resources of this country. Right? So point D already uses up all resources. Is that correct? Now let's compare points G and D. Would you agree that point G has more cell phones and more DVDs than point D? Yeah. Right? Why? Because point G lies in that direction, which is northeast. Correct? If you have a point that lies to the northeast of another point, you can be sure that that first point involves more of both goods. Right? So the logic here is quite simple. If point D already uses up all the resources, there clearly won't be any resources left to produce more of both goods. Yes? So the point I'm trying to make here is that all points that lie outside the PPF, and when I say outside, I mean points like G, points like the one I've just drawn, point, let's call that point H. Points like these are not possible for this country to make. Agreed? Because there simply aren't enough resources to produce those combinations. Right? Now, the blue line itself, all points lying on the production possibilities frontier are possible to make. Correct? That's why it's called production possibilities, you see. Those are the combinations that are possible to produce, hence production possibilities. right? Now, what about a point that lies within? Let's consider this point here. Let's call that point I. Is point I possible to make? Clearly, it is possible to make because compare points I and D, for instance. Now, point I involves less of both goods as compared to point D. Am I understood here? Now, why does it involve less of both goods? Well, you can see that quite clearly. Well, point D is this combination here. Basically, 3 million cell phones and 9 million DVDs. That's point D. And point I is less of both. Is that correct? Do you see that clearly? Now, since point I involves less of both goods, well, point I can certainly be produced. In fact, there would be resources left over. There'd be resources to spare if point I were produced. Is that understood then? So we're getting the hang of this PPF then, right? Now let's look at our first fundamental economic question. Do you remember the first fundamental economic question that all societies are faced with? Somebody? From chapter 1? What to produce, exactly. What to produce. So let me write that question down. What to produce. What to produce. Now, in terms of this diagram, how would you translate that question into this diagram? Well, the question could be, of all the points on the PPF, such as A, B, C, D, E, F, and all points in between, which point should the economy choose to produce? Where on its PPF should an economy choose to locate itself? Should it, for instance, choose to be here? Should it choose to be here instead? Or perhaps here? You see? So the question, what to produce, can easily be translated into this production possibilities frontier diagram. Right? Which of the points on the PPF should a country choose to produce? Right? Now, what do you notice about the PPF? Well, the two properties, the two fundamental properties of the PPF are, first, it is negatively sloped. Now, what do I mean by negatively sloped? What's a negatively sloped line? A negatively sloped line is one that starts out in the northwest and ends up in the southeast. So lines like that are negatively sloped. You follow me? So this is a negatively sloped line. What about a line like this, which starts out in the southwest and ends up in the northeast? Those are called positively sloped lines. So this is mathematical convention, all right? So you notice that the PPF is negatively sloped. Now, what is the implication of that? What is the implication of a negatively sloped PPF? How would you translate that into words? Somebody? Well, the implication is that if a country were to produce more cell phones, it would need to produce less DVDs. Is that correct? That's the implication of a negatively sloped PPF. If you want to produce more of the good measured along the x-axis, you have to reduce production of the good measured along the y-axis. In other words, you have to go from point A, for instance, to point B, and from point B, for instance, to point C. So as you go from point A to B, what's happening? What's the difference between points A and B? Well, B involves more cell phones than point A. Point A has 0 cell phones, correct? Point B has more cell phones than point A, but point B has less DVDs than point A. Correct? Now, what's the logic behind that? Why does something have to be given up in order to get more of something else? In one word, scarcity. Precisely. In fact, the resources are scarce. That's why countries have to make these choices. If you make more of something, you have to produce less of something else. Right? So the production possibility of this frontier is negatively sloped. And the reason for this, as I said, or rather as you said, the reason is, right, exactly. Now the second thing that you will notice about PPF is that it is bowed out, which means that it is not a straight line like this, rather it is like that. Correct? Now there is a mathematical way of expressing this as well. We say that the PPF is concave to the origin. PPF is concave to the origin. Now what does that mean, concave to the origin? Now what's the origin of this graph? This point here, right? This here is the origin of the graph. Now, if you were standing at the origin and looking out at the PPF, what would the curve look like? It would look concave to you. Do you know the meaning of the word concave? Well, if you're confused, just think of the word cave, right? If you were looking into a cave, what would the cave look like? The walls of the cave would kind of like be bowed out. Am I correct? So this is a concave curve. It's not a straight line, rather it is concave. Okay? Now, what is the implication of concavity? Well, you can see from this graph, and perhaps I can move to the next slide to this graph here. Now, what's the implication of concavity? You will notice something here. That let's say we start out at point A. So this is where we start. So the economy here is producing only DVDs and no cell phones. And now let's say this country now wishes to produce 1 million cell phones, right? In other words, this country wants to go from point A to point B, right? Now, in order to produce the 1 million cell phones, the first million cell phones, some DVDs have to be given up. Is that correct? Right? What quantity of DVDs would need to be given up in order to produce the first million of cell phones, according to this graph? 1 million, is that right? So this is how you would put it. You would say that the opportunity cost, of producing the first million cell phones is what? Now remember, opportunity cost stands for opportunities given up. In order to take a step, you have to give up something else. And that is an implication of scarce resources, correct? So what is the opportunity cost of producing the first million cell phones? Your answer would be, you've already given it to me, 1 million DVDs. Is that right? So the answer to this is 1 million DVDs. Agreed? Now, let's look at the opportunity cost of making the second million cell phones. Would the opportunity cost remain what it was for the first million cell phones, or would it have changed, do you think? What is the opportunity cost of making the second million cell phones? So now we're going from point B to point And when you go from point B to point C, what is the quantity of DVDs given up? What is it? 2 million, isn't it? So to get the extra 1 million here, you have to give up 2 million here. Right? And now let's consider the third million. Let's consider the third million cell phones. So when we increase this by 1 again, now we're going from point C to point D. And what is the quantity of DVDs that must be given up now? How much?
3 million.
Yes. So what's happening here? You see, what we have here is increasing opportunity cost. Is that correct? We have increasing opportunity cost. Now that is an implication of the concave shape of the PPF. And to make sure that you understand that, let me contrast this with a straight line PPF. Let's say the PPF were a straight line like that. Now with a straight line PPF, isn't it kind of intuitively clear that the opportunity cost of producing an extra million cell phones would always be a constant number? Right? Whether you go from here, let's call that point A, to point B, to point C, to point D. Well, as you go from point A to point B, to point C, to point D, you'd always, in each step, be giving up the exact same quantity of DVD. Is that right? Is that clear to you? So with a straight line PPF, you would have constant opportunity cost. On the other hand, with a concave PPF, we have increasing opportunity cost. Correct? So it becomes progressively more and more expensive to produce cell phones in terms of DVDs given up. So when I say more expensive, I mean in terms of opportunity cost, in terms of the other good given up. So it becomes progressively more and more expensive to make cell phones. Right? Now what's the logic behind that? Why do we have increasing opportunity cost? Well, the answer is like this. The resources that we're talking about here, resources are not alike. Now, to keep things simple, let me assume for simplicity that the only resource is labor. So this is a simplification, okay? So let's say that the only resource out here is labor. Labor is used to produce either DVDs or cell phones, right? And now I'm saying that labor isn't homogeneous. So let me write that down. Labor isn't homogeneous. What's the meaning of the word homogeneous? Just a technical way of saying every worker is the same. That would be homogeneous, right? But we're saying here that workers are not homogeneous. Every worker isn't the same. In fact, you have some workers who are very good at DVDs and very bad at making cell phones. At the other extreme, you have workers who are very good at making cell phones and very bad at making DVDs. So you have a continuum of skill. So you can think of it this way. You have a scale here, and this is a skill scale. At one end, you have workers who are, at this end, you have workers who are, let's say, very good at DVDs and very bad at cell phones. At the other end, you have workers who are very good at cell phones and very bad at DVDs. And then you have a continuum of workers in between them. Do you see what's going on here? So let's say we consider a worker here. Let's consider this guy here. Let's give him a figure here. And let's consider this guy here. What's the difference between these two fellas? on that skill spectrum. Now remember, this is the end where people are very good at DVDs and bad at cell phones. The other end is very good at cell phones, bad at DVDs. So this guy here, let's compare these two guys. Who's better at DVDs? This guy, right? Who's better at cell phones? Correct? So you have workers on this continuum. See, all workers aren't alike. And let me explain how this works, to explain concavity. So let's say that we start out at point A. At point A, all workers, whether they are good at DVDs or bad at DVDs, they're all producing DVDs, right? And now let's say we want to move some workers out of DVDs into cell phones in order to produce our first million cell phones. We want to go from point A to point B, in other words, right? Now, in order to do this, it would be sensible for us to shift out of DVDs and into cell phones which kind of worker? The worker at this end, meaning guys are very good at DVDs, bad at cell phones, or workers at the other end who are very good at cell phones but bad at DVDs. Which type of worker would I, and I say let's say I was the guy doing this, managing this whole transition, right? What kind of worker would I shift out of DVDs into cell phones first? The people who are? The workers at this end, am I right? Workers who are bad at DVDs and good at cell phones. Why would I do that? Because that way, when I move them out, since they were bad at DVDs, DVD production should fall by a small amount only, because these guys weren't very good at DVDs anyway. And then we'd get a pretty big increase in cell phones because these guys are very good at cell phones. Am I making sense? Right? But eventually, this is what's going to happen. Eventually, I'm going to run out, so I'm going to take bites. I'm going to take bites out of workers from this end, you see? I am moving workers. With each byte, I'm moving workers out of DVDs into cell phones, right? But you see, as I do this, I now run into workers who are, in fact, not very good at cell phones and very good at DVDs. Right? So what's the implication? So as I start to make my first million cell phone, my second million cell phone, I find that I have to now give up more and more DVDs. Why? Because eventually the kind of worker that I'm moving out of DVDs into cell phones will eventually become workers who are, in fact, good at DVDs. Am I making sense? Is this clear to you? So as I produce more and more cell phones, I have to give up progressively more and more DVDs, you see? The opportunity cost of making cell phones rises because I am going to eventually have to move out workers out of DVDs who are good at DVDs. And when I do this, I naturally lose a large chunk of DVD production. Is that making sense? So this is why the PPF is concave to the origin. Right? So we have these two properties of DVDs. First, negatively sloped, and that comes from scarcity. And the second property is that the PPF is concave to the origin. And the reason for that is that resources are not homogeneous. Right? Now we can talk about something called efficiency. Now, when do we have production efficiency? By the way, this is also sometimes referred to as technical efficiency. So when do we know that we have achieved technical efficiency? We know we have achieved technical efficiency when it is not possible to make more of one good without giving up quantities of the other. Meaning, it's not possible. Now, did you get that sentence clearly? It involves double negatives, and sometimes these are sentences like that are difficult to understand. So what am I saying here? It's not possible to make more cell phones without giving up DVDs. In other words, the only way that you can make more cell phones is by giving up DVDs. If we have a situation like that, we can be sure that we are operating efficiently. In other words, there is no slack in our system. Right? What do I mean by no slack in our system? No one, in other words, is idle. No resources are idle. Right? If everyone's working to their maximum capacity, producing either DVDs or cell phones, the only way that you can make more cell phones is by pulling workers out of DVD production. This will naturally result in a lower quantity of DVD production. That's the meaning of production efficiency. So we have production efficiency when the only way you can make more of one good is by giving up quantities of another good. Right? Let's contrast that with a situation of production inefficiency. So when would we have production inefficiency? Let's consider point H. Now point H lies within the PPF. What does that imply? Point H is certainly possible for this economy to make, correct? We've established that. In fact, we know that when point H is produced, there are resources to spare. There are some idle resources, correct? Now let's go from point H to, let's say, point E. If we go from point H to point E, what is happening? We are now producing more cell phones, but in order to produce more cell phones, are we having to give up some DVDs when we go from H to E? No, because it's a horizontal move, isn't it? Now, why aren't we giving up any DVDs to produce more cell phones? Because there was some slack in our economy. There were some idle resources, correct? Right? So all we did was we put these idle workers to work. Nothing was lost. We didn't have to give up anything. Is that correct? So that is the situation of inefficient production. Right? So where do we have efficiency then? All of these points, A, B, C, D, etc., these are all efficient. In other words, all points that lie on the PPF are, by definition, efficient. Correct? They are efficient because the only way that you can produce more of one good, the only way that you can go from A to B is by giving up some DVDs. Right? So along the PPF, we always have production efficiency, and we have production inefficiency within the PPF. Right? Trade-offs versus free lunches. So when production is efficient, we have to have a trade-off. In other words, in order to produce more of one good, we must trade off quantities of the other. We have to, in other words, give up quantities of the other. That's what a trade-off is about, right? A trade-off involves trading off something, meaning giving something up, right? So when you have efficient production, you always have to have trade-offs. On the other hand, a free lunch is a situation where you don't have to give up something. And that's when you go from point H to point E. That's a free lunch, okay? In this diagram here, or in this table rather, could you tell me the column that represents the opportunity cost of making cell phones? Which column of numbers here indicates the opportunity cost of making cell phones? The second one, exactly. This column here, well, this is the opportunity cost of making cell phones, right? In other words, to make the first million cell phones, you need to give up that quantity of DVDs. To make the second million cell phones, you give up more. To make the third million, you give up more. To make the fourth million, you give up even more, etc. right? So this clearly shows us that there is increasing opportunity cost along the concave PPF. Right? So far, so good? All right. Now, let me ask you a question. Let's say that we want to increase cell phone production by just one phone in the range AB of the PPF. In other words, we don't want to go all the way from A to B. We don't want to go all the way from A to B. Rather, we just want to go a little bit of the way. Do you follow me? We want to just increase our cell phone production by one phone, not a whole million, but just one phone. Yes? Could you figure out the opportunity cost of doing so on average, the average opportunity cost of doing so in terms of DVDs given up?
Would it be one DVD as well?
It would be one DVD. Now, how do you arrive at that figure? What we're doing here is we are what is called prorating. Right? Let me write this down. So in the range A to B, the opportunity cost of 1 million cell phones is equal to 1 million DVDs. Is that correct? Right? Now, how do we convert this 1 million into just one? How would we convert that 1 million into just one? Mathematically, that is. How do you convert 1 million? How do you convert that into one?
You divide it by 1 million?
You divide it by 1 million, precisely. So let's divide that by 1 million. But when you divide that by 1 million, since we have an equal sign here, we must do the same thing to the other side. You following my logic? Right? Because you have this side is equal to that side. So if you're doing some mathematical manipulation to one side, you have to do exactly the same manipulation to the other side. Because you have an equal sign between them. Am I correct? Right? So what are we doing here? We're dividing this 1 million here. We're dividing this by 1 million, right? So let me erase something here, if you don't mind. So in order to convert that 1 million into a single DVD, what are we going to do? Divide by 1 million. And we'd have to divide this by 1 million also. So what does that give us? In the range A to B, the opportunity cost of one cell phone is equal to one DVD. Is that correct? Are you following my logic here? So in the range A to B of the PPF, the opportunity cost on average, this is the average opportunity cost, correct? The average opportunity cost of producing one extra cell phone is one DVD given out. Make sense? Now, what about the range E to F? The range E to F. What would be the opportunity cost in the range E to F of producing a single cell phone by the same logic?
5 DVDs.
5 DVDs. How do you get 5 DVDs? Well, actually, between E to F, the opportunity cost of producing 1 million cell phones is 5 million DVDs. Is that clear to all of you? So 1 million is equal to 5 million. So how do you convert the 1 million into 1? By dividing by a million. And so you must divide the other side by a million also, right? And so the opportunity cost of making this one extra phone in that range of the BPF is, on average, 5 dBs. Yeah? So this is a simple proration, right? Okay, we've covered most of these things. And what I said just now can be translated into this statement here. Opportunity cost is a ratio. Let's think about that for a minute. Let me go back to a diagram of BPF. Let's consider points C and D. Now in the range C to D, what is the opportunity cost on average of making one extra cell phone between points C and D? What's the opportunity cost of making one extra cell phone? Not a million, but one extra? But 3 DVDs, right? How do you arrive at 3 DVDs? Well, you divide 3 million by 1 million. Is that correct? To get 3. Now, if you look at the little triangle that's been formed here by, the triangle CGD. You see that little triangle CGD that I've drawn here? Now, this is a right-angle triangle. Could you tell me what the slope of line CD is? Now, I did warn you that we're going to get slightly technical here. Can you tell me what the slope of line CD is? And can you recall what the meaning of slope is from your middle school / high school days? What is slope defined as? I don't have to worry if you don't know it. I'll tell you what it is.
Is it -3?
Hang on. What's the formula for slope? Rise by run. Do you remember that? Rise by run. So in this little triangle there, what's the rise and what's the run? The rise would be, what's the rise? CG. And what's the run? DG. Is that correct? Yes? And what does that convert into? What's CG equal to? Isn't CG equal to the same thing as this distance here? Between 12 and 9? Well, that's 3 million, isn't it? So that's 3 million. And what is DG equal to? Well, that's this distance, isn't it? How much is that? Between 2 and 3, that's 1 million. And your answer is? Yes? So you can now think of opportunity cost within a certain range of BPF as a slope. A slope of what? A slope of a straight line joining those 2 points on the BPF. So if I were to give you a hypothetical BPF like this, and I give you 2 points on it, let me call these 2 points M and N, and I'd like you to find the opportunity cost of producing one more good that's being measured along the x-axis. So just let me say one more x, okay? So let's say I want you to find out the opportunity cost of making 1 more x in terms of good y given up. How would you figure this out? You would draw a straight line between points M and N like this, and you would work out the slope of that straight line. Is that correct? So you would then do this. You would make a right angle triangle like this, and you would go rise by run. Is that right?
Is that a negative slope or that doesn't matter?
It is technically speaking a negative slope because this is a negatively sloped line. Is that correct? Right?
Does it matter?
Well, you would mathematically be a negative slope, but when you put it in words, of course you wouldn't say negative, right? You would say the opportunity cost of making 1 extra cell phone is 3 DVDs given up, right? Because it would make no sense to say the opportunity cost is minus 3 DVDs given up. That would make no sense. Is that correct? So you would ignore the negative sign when you're expressing it in words, right? So already I think you have a flavor of what economics is about. I did say in my first two classes that of all the social sciences, we tend to be the most sort of mathematical technical. This, by the way, appeals to some people, it puts others off. Okay? What kind of people does it appeal to? Those who have a logical bent of mind, or people who might have, let's say, become physicists, but then decided that they want to study human beings instead. Okay? And with that, I will stop here today.